All right. Good morning, good afternoon, good evening, everyone. Thank you all for joining us today. Today, we are really excited to talk about boosting your apps with an SRE approach to development. We've been working on this for a while, and we're really excited to show you what we came up with. Now, you might notice a little panel on either the side or the bottom of your screen. That's where you're going to ask questions. So while we can't answer questions during the webinar, we do have a section at the end of the webinar to address any questions that you have. So just go ahead and ask those in the chat and we'll get to them at the end. Now, today we have a packed presentation for y'all. We're going to first introduce ourselves, of course, and after we do that, we're going to talk a little bit about SRE and its origin. We are going to assume that many of you have heard about SRE or may even have an SRE job or have done SRE in the past. Regardless of what your history is, we're going to just cover the history a little bit here, as I feel like it's important to talk about that in context to what we're going to talk about later on in the presentation. After that, we'll do a small demo of an app without any observability at all. After that, we'll talk about adding observability to the app through logging and through monitoring metrics and performance. And then we'll repeat that demo with all of those things added on top of it. I'm really excited to show you all that. And then we'll talk about how you can boost your app even more with an SRE approach to development with some additional things you can do after this. And then we'll get to your Q&A. So before we get to the content, we'll talk a little bit about Contino. For those of y'all that have not heard of us before or have not worked with us before, we're an enterprise DevOps consultancy. We have offices around the world and have clients around the world. And our mission, our job is to help all of them get better at DevOps, understand DevOps better, understand what it means to have things like cross-functional teams or be able to deploy daily or weekly, or how to run microservices at scale, or how to manage their data. We do all things DevOps as well as all things cloud. We have clients on all the major cloud platforms. We also do cloud native work with Kubernetes and Rancher and Docker, and we also do work within the big data space. So if this is your first time hearing about us, I encourage you to visit contino.io to learn more about us. And you can see on the bottom of the screen some of the clients that we've worked with in the past. Now, let's talk a little bit about us. My name is Carlos Nunez. I am a technical principal at Contino. I've been at Contino for about 3 years, and prior to that, I've been in tech for about 15 years. Time flies, I forget whether it's 10 or 15. I've done SRE at Google and Namely, and I've also done SRE-like functions in financial services companies prior to that. And I've been consulting on DevOps and SRE for the last 4 years, give or take a year. And when I'm not doing that, I really like going to the gym, though right now that's unfortunately not possible given our current environment. But I do like going to the gym. I like riding my bike. I like beer. I like travel, and I like writing, and I like hanging out with my awesome wife. So you can find me at Carlos and DFW on LinkedIn, or you can email me at carlos.nunez@contino. Alex.
Hey everyone, my name is Alex Cornford. I am a lead consultant here at Contino. I've been with the company for about 2 years and some change. It's kind of hard to believe. But still, I've been working kind of as a DevOps engineer for my entire career. And I know we all have our own definitions of what DevOps are, and I can assure you that in one way or another, I've played a lot of those hats, from sysadmin to true cultural revolution within organizations, and something that I believe very strongly in. When I'm not DevOpsing or software engineering around tooling, I'm cooking in cocktails or creating cocktails, which is great in this climate, or I'm trying to climb, which, you know, is not so great so far. So if you want to reach out to me on LinkedIn, I'm Cornford, and if you want to email me, there's my email. Jager.
Hey everyone, I'm Edgar Gonzalez. I'm a DevOps consultant here at Contino. I've been at Contino for almost a year. Time flies. But yeah, my background in tech is I started off as a software engineer and quickly got really interested in infrastructure, automation, everything reliability. And so I like to say that I'm a software engineer who has a passion for automation and reliability and resiliency. So when I'm not doing that, I love hiking, drinking beer together, preferably, and as well as playing board games of various kinds. You can find me at Edgar G Dev on LinkedIn, or you can email me at edgar.gonzalez@contino.io.
Great, thank you guys. So let's spend a little bit of time on the history of SRE. What is SRE? Why do we need it? Where did it come from, right? And the reason why I like to talk about the history is because unfortunately, for whatever reason, there's this preconception in IT that SRE is kind of like ops, but it pays better. And the latter might be true, but that's the former isn't quite true, right? There's a reason why site reliability engineering or reliability engineering is a practice. So I want to spend a little bit of time talking about that. You may have seen this man before. You've probably heard of this man, Ben Trainer Slomes. He is widely known as the father of SRE, and for good reason. He was at Google when the SRE practice started. He founded the SRE practice, and he founded it based on a mission that was given to him to try and wrangle the scale that Google was experiencing back in the early 2000s. Now, Google back then was mostly software engineers, many of them with PhDs, and they were working on a really hard problem, web search. And web search is, like I said, it's a really hard problem, requires a lot of math, a lot of computer science, and they had a lot of software engineers, but they didn't really have a lot of systems administrators. I mean, they had a few, but they didn't really have many. And so Ben was tasked with a pretty challenging edict, which was to try and manage the various systems at Google, but use the people that he had to do it. And so the way that he approached the problem was to basically put a software engineering principle or software engineering mindset onto the systems administration space. And I think this quote really sums it up nicely. What exactly is site reliability engineering as it's come to be defined at Google? My explanation is simple. SRE is what happens when you ask a software engineer to design an operations team. So I think it pretty succinctly summarizes what he had to do. But why did he have to do this? Why did Google need this? Well, I'm sure some of you or many of you have been using the internet for a long time. And if you have, you probably remember other search engines that were out there prior to Google dominating the market, right? You probably remember Yahoo, Alta Vista, Jeeves, Lycos, the gamut, right? A lot of people were trying to get into web search for a really good reason. Having web search was pretty much having the front page to the internet. And if you wanted to find something on the internet, your first thought was to use a web search engine to do that. And so having Google conquering this space was really, really, really important. In addition to that, Google was using the traffic they were getting from search to power the things they were doing with ads, which is what Google is very well known for today. And so their experiments were working. Their page crawling technology, PageRank, was well and beyond what was available in the market even today. And so they were crushing it pretty early on. But while that's a good thing, since you get the market share, it's also a bad thing because now you have to deal with incredible scale, right? So Google there was no way that a traditional systems administration approach to managing this problem would work, where you have administrators who log into boxes with SSH, and you run PS or top to find out what's going wrong with each of the systems. You have like a ton of little terminals here and there. It works for a little bit, but it doesn't work at that scale. So they needed to be able to automate everything. And a lot of those principles of automating everything and using data to find out what's wrong is really the underpinning of what SRE is. And that's why Google had to take a software engineering aspect to this very niche systems administration problem, right? And we're going to observe a little bit why that scale won't work today. So today we're going to show you all an app. It's a very simple React, Rails, Postgres 3-tier web app. It's an organizer for GitHub projects. It's broken, and we're going to show you why. So I'm going to try and use this app, and Edgar and Alex are going to try and help me figure out what goes wrong with it. So without further ado, let me go ahead and switch over to that. All right, so here is my app. It's pretty simple. I can create a new user or return as a user. I have not created a new user yet, so I'm going to go ahead and do that. And now I am given the option to do stuff. So I'm going to click on my projects and add a new project. And I'm going to call it my awesome project. Or rather, my link to my image is, I'm just going to use a favicon for the page. And I'm going to say this is an awesome project. I'm going to say it's in progress because it's actually the project where you can find all of this code. So I didn't mention this before, but everything that you see here and everything that we're going to show you today can be found on GitHub at github.com/Contino/SRE webinar app. So you can go ahead and check that out, play around with everything that we're going to show you. It's all open, it's all out there. I encourage you to do so. So now I'm going to click submit, and it's going to create my project. But I'm actually curious about these buttons here, previous and next project. I wonder what else is here. That's weird. My project disappeared. I don't know how to get it back. Let me see, and I can't click my project. So let me just refresh the page. And it looks like I can't. This is really weird. It says process users undefined. Alex, Edgar, what do I do?
So can we take a look at the console?
Yeah.
Let's see if it's giving us any more info.
Okay. It says here the same thing that says up there. It says process users undefined, but I'm not really seeing much of anything else.
How do we store users in our front end?
Man,
Or
I don't know. How do I find out? I kind of just downloaded this from GitHub.
Might be worth checking out .js. We see that it's the file that's still in the error.
Let me go to my project. Hang on one second. Let's see. Sorry, one second. Okay, so here I am. So I'm checking out let's see what app.js looks like.
There's not really much to go on here.
Not really. I mean, there's this users thing though. I know you asked about that, Edgar.
Yeah, it might be.
Do you want to check the backend and see if
yeah,
what that endpoint's doing?
Yeah, let's check out the background. I mean, I don't know much about Rails. I mean, or Rails. So I hope I can be helpful here. Let me go to the back end. And I guess it would be a route, right?
Indeed.
So let's see what we have. App. Wait, let's see what's here anyway. Okay, we have a bunch of stuff. Let's check, where would it be? Would it be like an app or something?
If it's following Rails conventions, yeah, an app and controllers.
And users, right? Oh, users sounds familiar. Okay, so we have some things, but this doesn't tell me much.
I noticed there was a Docker file, Carlos. Is it a container running? Can we look at the logs?
Yeah, the container is totally running. Let me check it out. I'm using Docker Compose for this, so yeah, we have the backend here. So maybe I should check these logs.
Yeah, let's check them out.
Okay. Well, there's not much there, but there is a database. Maybe I should check the logs for the database. Huh, okay. Oh, error right there. Value too long for type character varying 10. So it looks like my username was Carlos Nunez. I think that's longer than 10 characters, so maybe that's a problem.
And we should check the migrations and see if maybe there was a constraint put on.
Migrations. Doesn't look like it got the migrations. Let me check my history. Here we go. So all the migrations are here. Modify users table. Limit 10. There we go. So yeah, there's a limit on the name. So maybe if I restart this app, it should work. So let me go ahead and try that. All right, so I'm going to create a new user.
Make sure it's less than 10.
It is Carlos C. Nunez. I think that's less than 10. All right, let me actually zoom in on that. All right, so let me go ahead and try the same thing again. I'm just going to type dummy characters, dummy strings, just to see if this works. Still broken. That's weird. Maybe.
Check. Where is it storing the user information? Yeah.
I think this might be in local storage. Let's see. Oh.
Yeah.
What if I change that to 1? It looks like it should be an integer. That's weird. Still broken. Now, I'm actually gonna stop it here because it looks like it might take a while to actually fix this. But the point that I wanted to really demonstrate here is that we went on gut feelings for a lot of this stuff, right? And when you're running a really large system at scale, like the size of Google or the size of a lot of your companies, for example, that's not going to work, because even though you might be able to get to the root of the problem, we don't really know what the root of the problem is. So we try a bunch of things to see what sticks. And a lot of the things that we try really goes based on gut feelings. And unfortunately, sometimes we get lucky and those gut feelings tend to work, but many times, at least in my experience, the gut feelings are just that. So not having any data to really go on anything, it makes it a lot harder to troubleshoot. It makes it a lot harder to come to the root of a problem, and it makes it a lot harder to maintain a system that scales vastly and widely, right? However, we can fix this, and that's where SRE steps in, right? So we're gonna spend the next few minutes talking about some approaches that we can take as an SRE to really get deep into the problems and use data to inform us on how to troubleshoot them. Now, I said this before, but I'll just say it again. Everything that you see here, you can find on this repository. So go ahead and check that out. I encourage you to play around with stuff, break stuff, whatever you want to do. It's all there. And now, without further ado, let's go ahead and talk about logging. And Alex will lead it from here.
Cool. Thank you, Carlos. So yeah, I mean, when we think about SRE, we think about how we can use all this data that's in our infrastructure and our applications to make decisions, right? Be it the automated decisions or be it troubleshooting decisions. We have all this noise and we want to figure out what's valuable and what's not valuable. And that's kind of in essence that we've been talking about. Go next slide. But in order to make decisions, right, we have to generate noise. And when I mean by noise, isn't necessarily that everything that's coming in from these applications or services is useless, right? But we don't know what the issue is until it's an issue. So having data from before and after, right, is pretty helpful. And every language that we have, every service, there is nothing stopping us from writing that information and useful information out, right? So every single language can do a put, or maybe it writes to standard out. It's always writing to a file, right? And that gives us some insight. We can say things like, okay, create this user. If the user wasn't created, put that out somewhere. If you're using containers, right, Docker is pretty handy in that it collects what's in standard out as a log. But if you were thinking of your more monolithic microservices, right, like writing the log files is something that is standard, but often underutilized, which is something that we want to avoid, right? So if we go to the next slide. we kind of run into this conundrum, right? We've all worked in places, or some of us have been on clients where that app that wasn't supposed to be in production is now in production, and logging is pretty minimal. And it's just kind of the way of the world, right? We want to have the ability to debug rapidly. We want to have these logs. We want to be able to see what's going on in our application, but it often kind of gets put in the back burner, right? And once we accept this idea that having logs of any kind are better than having no logs, even if it's just, hey, my app is working, suddenly it's not working, now we have a timestamp, we can get a lot of information from that. It can at least give us a starting point. We're not shooting from the hip as much. And that enables us to figure out the problems sooner and scale things and do the things that we're continuing to talk about. Go to the next slide. So with all that being said, right, there is good logging and then there's bad logging. I contend that bad logging is better than no logging, but good logging you really can't beat, right? So what makes a good log? Consistency is kind of the big key here, right? If all of our logs kind of look all jumbled and all over the place, and some of them are tabbed and some of them are not tabbed, it adds a lot of visual inconsistency. And that visual inconsistency is further illustrated by our inability to really interact with those logs, right? So if I'm writing all of my Rails logs to a file, I can grab that file and find relevant information very quickly. That no longer is true if it's all over the place, right? Logs should be descriptive. They should have severity, right? If an error happens, something that shouldn't happen happens, we want to make sure that's visually distinct from when, oh, the session took too long, or oh, there was a timeout here, or you can imagine, right? And so in order to do that, right, we want to make sure that we have a logging service, be it a logging library or one that we create to kind of take away the human error from writing logs. And that enables us to do things like stream it into Splunk, which goes to you, Edgar.
Awesome, thanks, Alex. So the next step up after you're logging to standard out or you're using Docker logs is like something like Splunk, right? A centralized logging solution. We're not really going to dive deep into Splunk because that's like a 10-hour course on itself, but we're going to talk about like the benefits of logging with Splunk. Next slide, Carlos. Cool. So awesome. You saw in our sort of demo how we were able to sort of get information out of the system just by like catting out the logs, doing Docker logs, right? But as you saw, we had to visit several places to do that. We had to go to one Docker container, Docker log, run Docker logs on it, and examine what are we getting out, right? This can become pretty tedious. Imagine you're trying to debug a system that involves 7 or 8 different components, right? Like I experienced, and you don't have a centralized logging system, right? It can take hours upon hours to figure out where is the issue, right? Where is the information I need in order to debug the system? So there has to be a better way, and that's where Splunk comes in. Next slide. So, awesome. Logs. We can use Splunk to centralize all our logs in a singular place. Give us one singular view, a singular plane where we can interact with our logs. The biggest benefit you get is you can query your logs. So for example, we can start searching for errors in the query bar and get all the corresponding errors that happened within the last 5 minutes, right? And this is especially important in today's age of ephemeral hosts, when we're working with things like Docker, serverless architecture, when we're dealing with scaling groups, right, where hosts are created, destroyed at a whim. We can't rely on logs to be stored on the host. So that's where centralized logging comes in place, right? Next slide, Carlos. Yeah, so like this is just a quick view of like the benefit of something like Splunk. There's other things like Stack Driver, the Elk Stack. the main thing they have in common is all your logs are there in a singular place. You have a singular place to be able to search through and interact with your logs. It's one easy view. They often provide tools like dashboards, awesome visualization tools so you can interact with your logs, do more advanced things that we'll talk about later, like tracing. Tracing is one of my favorite ones. But like the main thing I want to take away is that you can notice here that all our backend logs and our front end logs are in this singular view. So yeah, next, and then it's off to you, Carlos.
All right, thanks. So now we're going to talk about metrics and why they're important and why we're going to use Prometheus in the stack to track them. I love logs. I use logs as the first thing in my arsenal when I troubleshoot. And sometimes they get me to the right answer fairly quickly, but in a lot of times they don't tell the entire story. So if you look at this log cabin, right? I don't know how many of you have stayed in a log cabin. I've personally never stayed in one. I've only used the syrup. And as you can see here, this log cabin, there's a lot of logs here, but it's not really a log cabin yet, right? Like you're missing the interior, the foundation. I mean, look at that thing, right? It doesn't tell the whole story, right? Just because you have a lot of logs streaming into a system, even if it's centralized, it doesn't necessarily mean that you have it's a panacea, right? In my experience, many of the problems that I've encountered in production tend to go deeper than the logs tell you. So even if you have a log and you follow the log, upon deeper inspection, you find that it just leads you nowhere, or if it leads you somewhere, it just leads you to yet another clue of what the root cause of a problem may be. Sometimes you don't even know what the problem is, then there's just no log to tell you. And I mean, I've been in that situation a ton of times, and it's incredibly frustrating, right? So that's where metrics comes in. The idea of having a metric, or the idea of a metric, excuse me, is that it is a thing that happened at a point in time, right? So that thing could be anything. It could be whether, I was on a page and I clicked the button. That could be a metric. Me clicking the button, me loading the page, the CPU utilized to render the page, the memory available to the app or to Node or React at the time when that page was rendered. All of these things are metrics. The idea is you have a time dimension and you have some element of content, right? Now, metrics alone don't tell this whole story, right? Like you have millions and millions of metrics. In fact, one of the most common problems I run into at companies that have advanced performance monitoring or advanced metrics collection tools is that they have too much metrics, too many metrics. So a lot of noise, which makes finding the needle in that haystack more difficult, right? The idea is you want to have a collection of metrics over a given time duration or a time period. So that's the idea of a time series. And when you have metrics in a time series, you can do really cool things. You can dashboard those metrics to find out how long it takes on average to click a button and have the page do something, how long it takes, how much memory on average your application consumes over time, how much memory or how much CPU on average your app is using, right? From that, you can establish trends. So you can say, last week, based on this user load, we experienced it took this long to render this, to click this button and render the following page, right? And it was able to render between this time and this time. If you're retail, this may be important if you're working Black Friday or something like that, where you have an exorbitant amount of user load and you need to know and predict how to be able to scale to that user load without your systems breaking. In the SRE book, they call that capacity planning, or that's one of the elements of capacity planning, right? It gives you an idea. It gives you an idea of how an application is going to behave, which is really important when you're trying to harden your system and boost your app, right? If you've read the SRE book on that topic, you've probably seen something about the 4 golden signals. And what that basically means is that even though you can have metrics about anything, when you're trying to get a handle on problems in production, or you're trying to scale your production systems, the things that typically matter reduce to these 4 things: availability, latency, throughput, and yield, right? So availability tells us how often the service is available, how often the page is rendering, basically. latency tells us how long it takes for your app or your service to respond to various requests. Throughput or traffic tells us how many requests can fit during a certain time, right? Just like the image you see here, a highway is basically a pipe, and the amount of cars you can fit into the pipe is the traffic that the highway can take, right? Same deal with the service. And yield is how many of those responses return correctly. So sometimes this is a little bit more abstract, you know, because you can track, for example, with the web service, you can track how many HTTP 200 your app is generating. But even if you get a 200, that doesn't necessarily mean that the content is correct. So tracking this is a little bit more tricky, but you can still track it, and it's still something that's important to tell you whether your service is working. So in this stack, there's a lot of options out there to do metrics collection, but one of my favorites is Prometheus. I like Prometheus because its approach to monitoring metrics is really simple. It basically says your app is going to expose an endpoint, an HTTP endpoint, and it's going to have a bunch of metrics posted on that endpoint. I'm going to go and scrape that endpoint. I'm going to do a little bit of analysis with the data, and I'm going to dump it into a time series database, right? That's it, essentially. It's so simple that the server doesn't even have authentication or clustering. You have to set those things up yourself. So if you want more Prometheus servers, you basically set up more servers. If you want authentication, you run it with a proxy. I like this because it's very Unixy, right? Like if you've seen the philosophy of Unix, one of the more often touted ones is that a process does one thing and it does it well. Kind of like when you cat a file, it streams the contents of that file and that's it, right? Prometheus' only job is to collect metrics and that's it. You can connect it to various different things. One of the most popular things to connect it to is another service called Grafana, which is used to dashboard that information. Another popular one is Alert Manager, which allows you to create alerts based on metrics and their thresholds. But it's really simple, and everything can be expressed in code, right? Which is something I'm a big believer of. I love having all of my configuration in the same code base as my application, so that when I deploy my application, I can own that application from start to finish. So if you've heard the phrase, you build it, you own it, this is one of the things that is fundamental to being able to do that. And one more thing, I'm cheap, I love free. It's free. You can download it on GitHub, and it works great. This is an example of Grafana, and to the right is how you can spin it up yourself. So so there's a backend and a front end component, as you saw earlier. Both of those components have branches correlating to each of the topics of this webinar. So if you go to the 4th chapter, or tracking SLIs, which we'll talk about in a minute, if you don't know what an SLI is or haven't heard of it before, you can check out that branch and start up the service. The README tells you how, and you'll be able to get to this graph. And it'll show you things like the latency for each of the backend endpoints and the front end endpoints. It shows you how many are returning 200s versus how many are returning 500s or other, and it shows you other data. And the nice thing about this is that this dashboard is also in code. So you don't have to configure, you don't have to touch the front end to do anything. All you have to do is spin this up, and all this is available. And you can even add more dashboards or modify this dashboard, which is really cool. So now we've spoken about metrics, let's talk about tracing. And tracing is interesting because tracing is we'll talk about what tracing is more specifically in a moment, but essentially tracing is an application of metrics, right? So if we look at our 4 golden signals again, we get a lot of data between metrics and logging, but sometimes I want to really see the journey of something, right? When I click a button, I go to this page. When I go to this page and fill in a form and I click submit, the form gets submitted. The form gets submitted, the form goes into a database. Before it goes to the database, the data is analyzed, things are done. I want to see that whole journey, and metrics don't really tell that story very well. And this is particularly important when you're trying to determine the latency of an application from start to finish, right? So if you're working in a distributed system, you may have a lot of services that are responsible for singular things. I want to be able to see the latency between those services if I'm doing something from one service to another. And I feel like tracing does this really well because it gives you latency data for endpoints or functions or anything really. The way that you create a trace is through something called a span. So in your code base, you basically put in a block that says, I want to track how long it takes to do this thing. And I want to call it this. And I just want to see how long it takes from start to finish to do this. If you have ever been curious and looked at a use curl to dump the to basically dump the traffic to a page or dump headers and other things, you may have seen a header in the reply or in the response called xtraceid. Or if you're looking at your web browser and looking at local storage, you might see a trace ID key in there. One of the reasons why this is done is to be able to track an entire journey or entire flow from service to service and use that ID as the identifier for that. So spans can contain additional annotations, and one of them could be trace IDs or the environment or the application or whatever you have you. It's very handy because of that flexibility. Now, the purveying open source body of tracing is implemented by Open Tracing. And there's several different clients that conform to that spec, but the one that we're going to use for this stack is Jaeger. So Jaeger is a fairly popular open tracing implementation. It was developed at Uber, and it basically allows you to create spans and send them off to a Jaeger server, which then dumps them out into a database. Like Edgar mentioned, we can go into a lot of detail about how Jaeger works and the architecture of Jaeger, but that's outside of the scope of this webinar. I encourage you to read the documentation on how it works. It's very, very well written. But if you've heard of Zipkin, or if in your job you're using AppDynamics or Dynatrace, the idea is very similar. You import a library into your code, it supports pretty much every language, and then you tell Jaeger, I want you to instrument this block of code. And Jaeger takes that code, it runs it, and behind the scenes, it tracks a start and end time and some other data. And then once that span is created, it sends it off. The one thing about Jaeger that I like is that it supports a lot of different wire protocols for sending spans. So if you use Zipkin, for example, Zipkin, I think it just uses TCP. But Jaeger supports a bunch of different stuff. It supports Thrift, it supports gRPC, it supports HTTP as well, it supports TCP. It's very versatile. And here's a real life example of Jaeger in action. Again, I want to emphasize, you can run this yourself. If you go into this branch and check out the README on how to run this, you'll be able to see this in action. And these are various spans that were collected over certain points in time. Now, since this ran locally on my system, it's not going to show me super cool trails of stuff since everything was relatively fast. But you can see that we have two services. Let me see if I can get a pointer. Nope. Where is it? Oh, here we are. Spotlight. It's not working. That's fine. So in any case, yeah, you can see that there's a front end, the two services here, and you can see the traces that are here, and you can filter them down by operations and even by tags, which is really handy. And also a lot of other systems like Grafana can ingest Jaeger metrics and be able to put them on the dashboard, which is really neat. So now that we've covered a bunch of different tools to up your observability game, we are going to put them into action and repeat the demo that we did earlier, except this time we're going to repeat it with all these tools. So in the background, I've went ahead and relaunched our app with all the cool new tools added. So I'm going to go ahead and spin that up. And now I'm going to switch over to it. All right, here we are. So we're back at our app again. And I'm going to try and do the same thing here. I'm going to try and create it. What? Where is my pointer? Oh no, the demo gods are angry. Okay, there we go. I'm going to go ahead and do the same thing I did before. I'm going to create a username, a long one. We know that this is going to break. So I'm going to click submit, click on my projects, and I'm going to go ahead and add a new project. It's awesome. I'm going to use the favicon again and say, here is a project. I'm going to go ahead and put a link. And I'm going to leave the color blank. And here we are. Here's my project. I'm going to click next again to reproduce the earlier problem. The project goes away. If I refresh the page, it sends me back to a login page, which is interesting. So I'm going to go ahead and click on returning user to try and log in again. And it looks like it broke. Something went wrong. Earlier, we used the web console to figure out what went wrong. I'm going to do the same thing here. And it looks like the app is now logging to Splunk, which is really neat. And it's logging to this endpoint. So if you look at the README, you'll know that our Splunk instance is served over port 8000. So I'm going to go to that instance right now and log in. You can set your own Splunk password. The README shows you how. So I'm going to go click on search and reporting, and I'm going to ignore this. And now I'm going to just type error because that's what I saw. So now I see that error that I saw earlier, that e.user is undefined, but right beneath it, I see my name, which is interesting. And I see an exception that the value is too long for type character varying 10. Now, if you recall, it took us about 2 to 3 minutes to get to this point, whereas with this tool, it took us about 10 seconds. So if you notice how much faster we're doing this here. So now we know that my username is too long. So what I'm going to do is I'm going to turn my browser off and on again. So I'm going to restart that. Now I'm going to have to reshare it. One moment. So now I'm going to go back to my app. And I'm going to try creating a new user with a smaller username, like C Nunez. I'm going to try adding a new project with some junk. Here it is. It disappeared again, which is weird. Let me see if I can log in again. Ah, something went wrong again. Oh wait, I probably didn't use the right username. Let me try that again. Let me do. So it's still broken, but we at least know why it's broken, right? We know now that it's a lot easier to debug this app by going to Splunk. And if we wanted to, we can even go to, we can see that Prometheus is working. I just like to go to Grafana directly because I hooked it up for that, or that's Jaeger, never mind. I think it's an 8083.
I had to reshare your screen, Carlos.
Ah, no, okay, thanks. Here we go.
Oh yeah.
There we are. Post 808. I don't know, which one is it? 1? No. Oh, here. Localhost 8083. He's 8080. It's in one of these ports. I apologize. The demo gods are mad at me today. Grafana should be running in one of these ports, but the idea, and I mean, you can see Jaeger working here. You can see a bunch of the traces that are happening. As you can see all the active record and controller activity happening. You can see that for the back end as well as for the front end. And what's really cool about Jaeger is that depending on the library that you use, you can actually see the errors inside of the traces like we see here, which is really neat. So that's it for that demo. Let me go back. So now that you've seen what you can do with, observability on your side, there's even more things you can do to boost your app. So let's talk about them.
Yeah, so like one of the first things that you can start implementing are healthiness and readiness and API inputs. Some of this is already given to you if you're using stuff like Kubernetes and A lot of Docker orchestrators provide this, but the main thing is, is your application providing an endpoint where you can sort of repeatedly check the healthiness of it, right? And with the centralized like logging systems and all these tools, you can see what percentage of it, what percentage you can start recording, like what percentage of the time is it up and healthy and stuff like that. Gives you better insights into your system.
In addition to that, yep, sorry, Alex.
I was going to say, you know, because we are able to track a lot of this information, we can start setting up synthetic use cases and tests. Seeing if we can get to our app from China or from the Netherlands or from Japan or what have you, right? And we can track that information, especially if we're doing it programmatically. We can treat it as if we were treating a test.
Right. So another thing that I've worked with in the past that I really liked is having exception monitoring. So like you saw in Splunk and even in Jaeger, there were some data around exceptions that occurred in our app. But exception monitors are really good because they focus explicitly on exceptions. So you can see things like stack traces. You can see things like you can drill into them and then see like where in each of the libraries that were called where that happens, which you can do in your own IDE, of course. But it's really nice to be able to do it in a tool and see it with conjunction with other data as well.
Cool. So there's also this idea too, as we were recording session information, there are more tools coming out. It's sort of in its early days, but you can imagine a world in which we start simulating user activity on our application, right? So we can use the techniques we're using for tracing to do user simulation within our application. So imagine a world which during our integration tests, right, we are running in these die tests to figure out if things are breaking or if they're within acceptable bounds. There's also this idea of using these metrics to generate our future user stories, right? So when we're thinking about the longevity of our app, what we want to do in feature prioritization, perhaps a feature is lowering latency on a heavily used service, right? That is just not possible without this insight that we're giving ourselves. And the purposefulness of it is giving us a lot of capability that we would be lacking otherwise.
Cool. Also, I just went back through my stack and I saw that the dashboard is actually a port 3000. So I'm going to go ahead and show that really quickly just before we wrap up. So let me go ahead and do that. So here we are. If I log in as the Grafana user, we can see that we already have a dashboard. So if I go to dashboards and home, we should be able to see our dashboard somewhere here. I'm surprised it's actually not showing up. So it looks like the demo gods are indeed mad at me. Oh, here we are, SRE webinar app. So we can see a lot of data here, right? We can see the latency from the front end as well as the back end, right? We saw that the user's endpoint specifically went up a little bit because we refreshed the page. We can even see this live. So if I open this app again in another window, if I keep refreshing the page, every time I refresh the page, it makes a call to users to see if there are any users defined. And they should see that spike up right there. See that? So our users just went up in the back end, right? Because I was just hitting it. This is really nice because you can see abnormalities or anomalies in your system, right? So if you see one of the backends just behaving extremely erratically compared to the others and compared to your data from your trends, you can probably surmise that either you just had an extraordinarily good event at your company, or more than often not, something is wrong. You need to look into it. So cool. Let me go back to our presentation. Right. So now we have Q&A. Let's see if we have any questions. So we have a bunch of questions. Let's go through them now. So Dewani Shah asked if this is being recorded. It is. The link, I believe we'll be sending the YouTube link after this is done. I have to double check, but it should be on YouTube within a day. So we make sure to get that out to y'all when it's available. Dennis asked if we're measuring SLOs and SLIs. So in this particular example, we didn't go too deep into that because we just wanted to show, we wanted to show a basic concept of how to use these tools. However, if we go back to our dashboard here, we can see that we indeed can track SLIs. So for example, we can track our two HTTP 200s, right, to determine availability. So or we actually are tracking latency pretty directly here. So this tracks how long it takes for each of these front-end endpoints to respond, right? I've seen really cool dashboards that track things like error budget, which is essentially the SLO that you committed to less it's available, one less the SLO that you've committed to. So if your SLO for availability, for example, is 5 nines or 99.999%, you can say that 0.001% of the time you can breach that SLO or be unavailable, right? If you do the math, that probably comes out to a few minutes. SLOs are determined by time period. So if you have an SLO to which you'll uphold 5 nines within a month, your error budget would be about 5 minutes a month of downtime. And every time that you see downtime or every time your 5xx counter goes up, your error budget goes down. And based on that number, you can determine things like whether you need to stop a release or whether if you're releasing daily, whether you should release less frequently and focus on fixing bugs, right? One of the things that I found an SRE can do is advise other teams to tell them whether it's safe for them to release their app or not. They don't want to be a gatekeeper, or they don't want to be someone that tells them no all the time. They just want to be able to basically avoid them from having problems when something goes wrong, but also avoid their own pagers going off when something goes wrong, since they're the front lines of defense, right? So again, I would just want to remind you, you can check this out yourself. If you check out the GitHub project or the repository on GitHub and run it based on the README, you can run this yourself and play around with the dashboards or add even more metrics. Another question here is, what are your thoughts on overops for app tracing? So the Wani Shah asks us this. That's a good question. There's a lot of tools. There's a lot of tools out there that are marketed to be specifically for performance management for applications. So there's New Relic or Datadog APM or Dynatrace or App Dynamics. There's a lot of tools out there, and they're really good at what they do. I like using this approach, especially for an example like this, where I'm showing how all this, or we're showing how all of this works, because it shows you how all of them fit together, right? And if you go into the code base, you can see all the work that we did to get this app instrumented properly. And it's a good first step. Obviously, App Dynamics, they provide a lot more features. I believe they have synthetic monitoring built in, for example, and they can give you really nice reports. And of course, you get really good support that comes with it that can help you even hone in on your SLIs even better. But I believe that this is a really good first step, especially for new applications where you're not really sure how it's going to be received in the market, or you're just trying to test the waters, for example. Alex, Edgar, do you have any other thoughts on that?
No, I think you summed it up pretty well.
Okay. So that's all we have. I'm not seeing any other questions here. Again, if you have any other questions, feel free to email any of us, or you can respond to the YouTube video that we'll post later as a comment, and we'll get back to it. Feel free to ask anything you want, because we're here to help. Our next CloudFest is going to be on April 30th. In this CloudFest, Ben Saunders is going to talk about why digital transformation is so key, especially now in the age of COVID-19 and lots of teams working from home and trying to figure out what that means for them. So check that out if you're interested in learning more about digital transformation in the age of COVID-19 and in general as well, and how you can do that well. But that's all we had for everyone today. Thank you so much for coming to our webinar. Feel free to play around with any of this and ask us any questions. We're here to help. And we hope to see you all soon. Thank you for stopping by.
Thank you, everyone.
Thanks, everyone.